find the area under the standard normal curve to the left of z equals negative 0.23 plus the area under the normal curve to the right of z equals 1.3. So we're looking at two things here. So first we have, and again a rough sketch is here. Don't like that, not bell-shaped here. We want a bell-shaped distribution. So we're looking at to the left of negative 0.23. So z is less than negative 0.23. And then we want to the right of 1.3. So that z is greater than 1.3. So one thing, we can calculate them separate and then add them together, right? And then maybe you see another way to do it. So we'll talk about that in a minute. Right, so let's compute these separate. So let's click back on our standard tab. And still a mean of 0, standard deviation of 1. So we have less than 0.23. And I'm going to write down the entire decimal. So 0.40904588 to get this accurate as possible. We're going to switch to greater than, and we're going to look at 1.3. So this is 0.09680048. So let's add those together here on our calculator. So we have 0.40904588 plus 0.09680048, and we get approximately 0.5058, right? So this is one way to do that. So another way to do this, right? We think about this. We draw on our curve here, and we're adding those two together. Right, we know that StatCrunch will only do between, right? So we know that everything under that curve must be 1, right? So if we think about actually finding this blue region that I just marked, so what's between those two, right? Then we can actually do 1 minus this blue region to give us that area. So let's do that, right? Let's change this to 0.23, negative 0.23, and this one to 1.3, and hit compute. And we're going to do 1 minus 0.49415363. And you'll notice that we get the same answer. Right? So there's a couple different ways you can do these problems, right? So you just kind of pick whichever method works for you. There's no one set way. You'll notice that they walk you through using the table. They may walk you through using a calculator. You'll see several different videos. Just do whatever makes you feel comfortable to solve the problems.